I think it's an interesting topic. So many people are interested, and especially if you work on the Cookstove. So we had a few people connected online. That's the way to try to solve this problem.
Actually, you know, the microphone is turned off.
No. So that's for participants.
Trigger?
That's to stop them talking.
Yeah.
We muted them.
The red one is muted.
No, but you see the green camera next to it? It's the microphone that's...
So if it is red, it is muted. But if it is not, it's actually terms are muted.
Oh, we do not. Okay.
Maybe yours is also...
All right, we're in.
So everyone can hear us. Let's start.
Everybody's happy. Okay. So, yeah, the context. You immediately think for anything when at a test, was it tested in a way that is meaningful to me to know what it's going to do? And the simplest example that everybody would understand is, so I'm testing a car driving on the highway. It doesn't tell me much about how it would perform in the city. So with that in mind, we will move on. So we're building on a success, which is in Mongolia. It's a project of World Bank, Asian Development Bank, Millennium Challenge Corporation, and Ulaanbaatar City. We have replaced 75% of the small domestic stoves in the city. Where the budget so far is about $35 million, and we have got a 22% improvement in the city's air quality 2 years in a row, for 45% improvement in only 2 years. And that project continues, and we will move on to the next stove. So this is a spectacular success, and it's caused because something in context. We selected the products in context. Stove performance is strongly affected by user behavior and type of fuel, of course, and then what you do with it, and then, of course, the stove itself, how it deals with the thing you did. Stove performance is not inherent. You can operate a stove and make any metric terrible or good, and don't want people cheating. We want people to do what they do, and we want to see how that stove deals with what was thrown at it. It found that although 40% of households primarily cook with biomass, a lot of them use LPG. Some as less 3 kilos in 2 months. But they use for particular things, and we are interested to know what they use it for. Can we apply that? And similarly, 40% of the households cooking with LPG, in fact, 70% of them use biomass, and all use it to heat water. So you get the whole 40% at the bottom, and 70% of the 30% above that on the income scale are heating water with biomass, but there's no call for a water heater. Everybody does it several times a day. So we actually said, let's look for these 2 types of devices then, and we'll offer to subsidize them. It can do the things people actually do. So the first is, of course, cooking, lower income groups, and water heating. For the majority of everybody in Indonesia, it's way more than 100 million people that are using this. So that's last. We didn't actually get any offer yet of a dedicated water heater, but I'm expecting is something that's a bit like a wood-fired kettle that you light. We call it fire and forget. You put it, you light it, you walk away, it boils the water and shuts itself off. Isn't that what we want? Of course. So the national context, Indonesia has 10,000 occupied islands, a huge range of fuel. A lot of fuel is wasted or burned to get rid of it. We have a variation in food pot sizes and cooking cycles. And the project is a results-based finance. For results only, we have to be able to predict what the result will be in the field. We start to roll out. So drove us to consider the system which had been used successfully in Mongolia since 2009. So this is a local context, and I've only selected a small number of stoves to show you today. This is just one, and this from Gorontalo Province, Indonesia, and this is a very efficient device, and it does 2 things at once. It can cook on top. It's air cooled. Those little slots there are the air controls, so it doesn't have a lot of air passing passing through it. And the shelf in front with the little arms is for putting shish kebab sticks, because people rake the coals out of the fire and they roast their meat on top, and it's very common. It's called satay, and this stove is in fact a roasting and cooking stove. It's a locally made traditional stove. And I want to improve this. It's quite a challenge because most stoves can't do that. People bring little round pots. So in the individual context, now just one family, what do they select? What burn cycles do they use? How many pots? How big are they? What's the cooking style? We want a stove will perform when operated in that way and that way and that way within a single family, because people have different meals. Also, we found most people had between 3 and 5 stoves of different sizes, so we can't offer what it's called. Whatever you sell them, they're going to use something else as well. So to support the objectives of the pilots, we want a market-based sector development. We want this to be, when we disappear, it has to be viable. We are technology neutral. We have to be very fair in when we consider them. The incentives are based on results achieved. We are only paying if you sell 70%. If you use it and it performs the way it was supposed to, 30% or a portion of that 30% if they don't really use it. And the requirement is we need a testing framework into we can plug these pots, fuels, burn cycles in the focus area. And we have 2 focus areas. We actually need one method, but we need 2 quite different sets of tests in terms of what we're going to do to light it. The Central Java, people are using a clay stove, an open fire, a 2-pot stove with no chimney. That would be the baseline. So there's 3 quite different baselines. Very little charcoal used, mostly by vendors in the city. And homes have 3 or more different stoves. So the baseline is a large, open, 3-on fire, and the pots are highly variable. There's a wonderful photograph on the Collaboration for Development website showing a picture inside an Indonesian home. It has 7 stoves burning 2 fuels and 14 pots on the wall. And you look at the size of those pots and say, okay, test stove. And I will reply, doing what? You tell me, is it frying, whatever. So these performance metrics, the bottom line, they are the fuel efficiency, the carbon dioxide, and the PM 2.5 emissions. And there are targets there, and we have benefits for the person, Market Aggregate. That's a lovely name. So this is what the user, this is our conceptual framework. We have ours. Oh, it's about this and this and this. This user's conceptual framework. Can I cook? Can I turn it down? Can I control it? Will it burn all the fuels I want? There's a lot of fuel. Can it hold all my pots? Or the pots I think a stove that size ought to hold, sliding around. And it makes sugar, because many of the people in the target area make sugar from palm juice 4 to 8 hours per day, and they only cook for about 3. So the stove spends most of its time earning money. And it could reduce emissions and exposure. They also are aware of that. So the first to do was to observe cooking and test actual meals. Now, this could be making water and putting it in thermoses, making breakfast, steaming rice, making some paste, and then heating water to wash the dishes. That's one cycle because that's what people do. And so the performance capture, this is done by the social science team, and they require trained by the technical team to be able to do that. They actually have to come back with some hard numbers, which are not part of their normal fare. So we have a little training in the lab, and we give them a very simple bit of equipment and come back with very important information, which allows us to predict where a stove is acceptable or not, at least a bit. So this is cooking test 1, and this is a breakfast. This is heating water for half the green, then to steam to get it boiled, and then heat the water in the stove block. The right section is the steaming of the rice, and at the end is the preparation of water for washing up. So this is a very high power cooking test 1, and selected as cooking test 2, cooking coconut milk chicken soup deliberately selected because it has a 55-minute, very low-power burn. In the highest of the high power and the lowest of the low power, people expect their stove to do those two things and be able to be controllable. So this is boiling the chicken and getting it going, and then simmering it, and if your power is a little bit up, it burns it. And like burnt food. That's the challenge. Now, by mathematically combining them, we will make a technical test. The technical test is what's actually conducted in the lab, and it consists of a number of cycles. The minimum we're using is 2, and in our pilot, we're only using the 2 cycles. Use as many as you like to represent the community. So if someone comes back and says there are 6 completely different things that people do, and combined to an average of behavior, and you can weight them by frequency, for example. And when you do the technical test, it is actually a prediction of their average performance in use, not a particular meal. But looking at what the meals do, measure performance during cooking in the lab, they come and cook in the lab, we can make a technical test. So we can weight the period weekly or monthly or seasonally because people's foods change seasonally. So we do that. So technical test design, we try to capture, I'm calling this the heat flow rate. The heat flow rate is the heat going into the pot per square centimeter. This may apply to any pot size. So do not report cook power in watts, because if you have a bigger pot and a bigger stove, that number is relevant. Heat per square centimeter tends to be quite constant. So range of pots, places, people, and stoves find that the heat flow rate into that women consider acceptable performance is 2.7 watts per square centimeter in Central Java. It died in Sumba. They want 3.5 to 4. They want huge fires. They want 25 liters of water to boil now. And that's cultural preference, and if you bring something that's 1.8, they will not accept it. So we're able to get, during the technical test, something that represents average use as well as the prediction of acceptance that it's going to perform, quote, adequately. And we interview them. How much to boil this water? Oh, 15 minutes would be great. How about 20? Not 20, okay. 25? I guess so. 30? No way. That's the heat flow rate, tells us that for any size pot. The technical test burn cycle with a section of high power, a section of the steam rice power, a section of the coconut, and the boiling of the water at the end. And this requires the stove to be turned down twice and to be turned up rapidly to high power at the end. And so far, all the stoves have been able to do that, and the emissions during these times are quite different because, you know, when you fire the thing up, it might go. We get sometimes emissions at the very end, so the highest power at the very end.
So how do they do it? Could you describe how they...
Well, most of these stoves are just sticks. You feed sticks in or pull them in or out.
The more
Yes.
you feed in, the higher the power.
The in Central Java are very highly skilled at running this and actually put in the fuel that they know will burn down slowly. And it's considered to be a highly appreciated attribute of a stove to put in just the right amount to get the power you want, and that it should turn itself down. They will walk away knowing that the stove will do exactly that and not burn the fuel. When they come back, the food is there and they can keep it low power. And they didn't particularly like, LPG can't do that. There's a reason for people to that feature.
You're talking of a baseline stove, more specifically.
Well, they would like us, yeah.
Talking of the existing
Yes.
baseline stoves.
Some of the new stoves can do that, and some are not at that. They don't turn themselves down. You have to control something. They don't tend to burn down. So these are the cooking tests. We get these metrics. We get the total CO, the total PM, and the total heat gained by the pots. And we get that for multiple burn cycles for different meals, and we can add them up. And then with technical test, the technical test times 2 to the sum of the 2 cooking tests, and we're able to get that within 10%. It shows that the technical test does represent the sum of different cooking cook and say, even they're quite different. So we get far more metrics from the technical tests. We got lots of things there. So this is the layout of the lab. You can have a look at that later. This was developed at the center at the University of Johannesburg, and then it was copied for a project in Mongolia, and by the Asian Development Bank, and then relocated, and is presently being much upgraded and expanded to be able to do water heating stoves with radiators and so on. That's being added as we speak to take on the next section, which will be small houses, heating systems in small houses in Ulaanbaatar, which we haven't touched yet. But it works the same way. This is the same in the lab in India at Java, their national lab built in Jakarta, starting next year. You see there's a hood and a chimney. So the chimney stoves, the sampling is done directly from the chimney, and here we just have a hood. Here's our fresh off the stars earned, the little red stars. These what the stove scored on its 3 chances to get a star, and you could get as many as 9 stars, and this top one got 8, which is really good. And draw your attention to the coefficient variation on these results. These are only 3 tests, and see that these are really low. So the test, what and how it's calculated, is precise. It's giving us, we can put in a category or above or below a line, like a national regulation. We can put it pretty accurately. And there's here at the bottom one, a high enough system efficiency. This is a measure of the fuel consumption. Didn't rate plus, and because it doesn't get 1 star, it doesn't matter what else it gets. It can't be worse than the baseline, and it can't be just as good as the baseline. It has to be a bit better, and this one didn't make it. So that's just I think 17 submissions. And about 2/3 of them have done really well. In 2 years ago, the way we were going to have this kind of result. It's spectacular improvement in the stove design community to get to this stage in such a short time. So
one question: what sample size?
Only just 3 tests. Yes.
Test.
We do the same technical test 3 times.
Okay. Coefficient is calculated over 3 trials.
Yes. The standard divided by the mean. Yeah.
Okay.
Yes.
But the efficiency there is efficiency in terms of efficiency in terms of the fuel, the fluid, or
I understand the question. Okay. So the efficiency is a ratio, so you have to pick a number on the top and you have to pick a number on the bottom. So which ones shall we pick? And I have there's some questions later, but I can show you a slide about that. The direct answer to your question is the heat gained by the pot during the test, which includes the heat gained by the pot itself and that went into it. And we actually replace the water in the pot to make sure we know exactly how much heat is gained at all power levels. So we can determine quite precisely how much heat would be gained if you continued to cook. And based on that, we can actually predict when it would boil or how long it would take to boil at any particular amount. That's the top figure. How much work would that get to be able to use for cooking? The bottom number is the fuel consumed to reproduce the burn cycle. And carefully defined as the following. It's the fuel needed to replicate the burn cycle in a series of identical replications, the first. And we see not the first one because people take wood of fire and put it in the next fire, and we look for that. So if there's wood left over that's going to be reused, use it in the next fire because that's what people do. There's waste, bits of coal left over which is not used, that's thrown away and is consumed. So every time you go to cut a branch from a tree, we weigh that branch. Each time, if you were to do it 20 times in a row and recycle your fuel forward, that people actually do. So take the energy that's required from the forest, and that goes bottom of the equation. This was, National Standards Committee preferred the term the overall thermal efficiency. I've used the term the system efficiency, but it relates directly to fuel consumption. For efficiency is a measure of something happening inside the stove. It does not report fuel consumption. So you have to be careful when said, my stove is X efficient. Which number did you put over which one?
One is very relevant for the household because this is how much wood they have to get or to buy in the market. So it's directly relevant.
If you were trying to say, I need a stove which uses at 50% less fuel, it has to measure how much fuel, if you really did this every day, how much do you have to go and get every day. And for a stove which doesn't have a recyclable fuel, nothing left today will be used tomorrow, then whatever goes in it, that's it. Tomorrow you must go and get some more, and that's the fuel consumption.
Right, very open floor to everyone for the questions. Let me introduce Helen Cox, who is in the social side of this initiative. I think this initiative really a collaboration of multi-discipline teams, and really benefit a lot from the social teams that the anthropologists, field study, and the household survey. And a lot of those information incorporated in the technical design, the testing protocol. So,
Yes. Thank Kristen for your presentation and for inviting me. So I am working at World Bank as a social scientist, and I was part of this team. And Teak, who's sitting in the back, was also part of the team. And Laura was sitting here. So we had we had a multidisciplinary team, sociologist, anthropologist, engineer, quantitative researcher that helped us. And Monica, who was the main researcher, she's supposed to be on, but I don't know. Where are you?
Maybe back to see who are on the.
Okay. So Yabe asked us to send some discussion points. So I did that. So basically, what we did was to contribute to this work, focusing much more on what makes people use stoves, how to contribute to the uptake, to stay used over time. And for that, you really have to have a very good understanding of the realities on the ground. It's not having a stove in the world if it's not the right stove for the use. So that's what we did. So we had field, and we worked with the local NGO in Indonesia. Mixed methods, quality focus groups, interviews, and we had a quantitative survey, and we had the anthropologists to join us. Did more of an ethnographic study. It was really a mixed approach to the work. The survey had almost 1,500 respondents, 200 respondents for focus groups, and the participatory observation was 15 households. So quite a broad spectrum of people involved in this. And what we found has already been feeding into work, as Kristen talked about. So I just wanted to mention a few things to spark the discussion. One thing that came out very strongly is that there is a clear disconnect in the stove and the development community sees as the needs and what the consumers really want. So the development community looks on improved health, less emissions, and efficiency, improved resource use, reducing women's workload. And research, and Kristen talked a bit about this, having the stove cook fast, high heat, easy ignition, efficiency, using less wood, and so on. These are issues that are much more important. So from a community's perspective, we are interested more in common goods, with perhaps delayed individual benefits, with exposure to smoke and good health outcomes. And the stoves on their side are much more interested in the functional side of things. They want immediate and concrete benefits. They want stoves that are fast and powerful and really respond to local needs. Not very strongly. And then I was looking at some materials I had, and I found this presentation from Cookstove Tanzania by the Global Alliance, and they had very similar findings. And one I thought was interesting to illustrate further. Basically, it's talking about comfort. So you want uptake, not focusing on what's on in Tanzania, but on the comfort. People and the health impacts of open fires. The student concerns don't outweigh present economic realities. That we sell the stove. For example, you can do something like this: cook in your best dress. Maybe a better way of selling the stove than talking about the impact of your children, because that doesn't resonate. It's a big message. You have to have a very deep understanding, and this doesn't resonate. So we put ourselves much more, I think, in the end user's shoes if we are going to be successful. And the issue that came out too was that more of a holistic approach is needed. And in this way, the role of gender issues came out as being very important. And they're critical in helping us understand the issues at stake and the design of the stove. So just to illustrate this point, women are the main users, and they are the ones who are most exposed to smoke. But they may be able to use some of the stoves. Their decision-making authority in the family may be quite limited. So the decision-making authority would fall the men, but they'll not be directly affected by the smoke or by the stove or by the product that goes with it. So you not see the benefit of it. So women have a much more limited decision role. They may be able to make decisions about money, but the big money is the responsibility. This is found in Indonesia. It may not be the case elsewhere. So when stoves, they buy cheap stoves that are quite fragile because that's all they do on their own, and that may not be the right stove for their needs, but that's all they can do. So that relations in a way distort the market. So we addressed this. And one concrete aspect of this would be to price the stove with the threshold of women's decision-making authority. So if it's that women can just buy it without having to ask and negotiate in the family, maybe the uptake would be better. Another area that they were focused on was more on a holistic approach in terms of improving the kitchen itself. So it's not just the stove, but ventilation issues and the kitchen design as well are important if you want to have an impact. Just some of the recommendations then that came out of there is a need to really integrate interest of the consumers from supply and demand, really focus on what the end consumer wants, and that's already starting. Seeing the different preferences of men and women is really important. And the areas of improvement that are important to the users, we can already talk a bit to that. Focusing on functionality and simplifying the stove so it's easy to use. And also using feedback mechanisms to improve the design and distribution and outreach. Some of the we had, and I can go into more if you have questions. And just quickly on the where we are in terms of next steps. So we have done pretty much all the field work. We are focusing on developing sort of calling it a social protocol for a better name, although I think we may need a better name, but sort of a protocol or guidance that can help us involve end user much more systematically in testing of the stove. Some elements have already been integrated. We want to push this a bit further. So we're now developing sort of a draft protocol. Veronica, who is not with us right now, who's been leading this work, is actually going to go out to Indonesia and test this with the end on the ground and hopefully come up with a nice model that can be used. And then we would use that together with the more technical lab tests.
What kind of protocol this is?
So basically, the protocol will focus on engaging the end users in a systematic way. So inviting women to come in and test stoves, but doing ways that you can compare, so it's not random, and giving the sort of a protocol to follow how to do that in a systematic way. So we would start very simply and use steps or guidelines. Maybe it's better than a protocol. Protocol may not be the best word. More like guidelines how to do this.
And the goal would be then to assess the user preferences and needs, or how they the and preferability of the stoves.
They would be to provide the end user test stoves and provide feedback, and that feedback minimum given to the producers, and then they would have this information as additional information. They can leave it, but at least they have more information to base their design on. That would be.
I think in the end, the whole purpose is make it user-friendly, user-centered design and stove program. Because before, there's some disconnection between what we want from the development agency or donor perspective and what the user wants. And that's the key reason there's in the past not many successful stove promotion programs. Because if you go to the field, actually what attracts me is that there's a reason people use 3 stoves. They can make a stone, they can make it bigger for the bigger pot, smaller for a small pot, and they can adjust the fire quickly. So there's so convenient, so much advantage of using the 3 stoves. So if we want to promote a stove that actually be sold on the market, actually could be adopted by the users, you need all those expectations to compete with the traditional stoves. So that's, I think, that's what we try to do, to understand of what the user perspective and provide information to the designer, to the manager, to design a program that can really successful. And we want the market to be successful. We want the user or designer to be successful.
This is throughout all this program, we've been moving from qualitative to quantitative, or kind of similarly all along. The qualitative has informed the design of a protocol for testing, which provides a number of results. The qualitative has also reinforced the value of this information that is actually representative of what we see in the area, not just 3 households who happen to be doing it this way. Then the qualitative again is the analysis of a stove, which gives some results on the OPM and so on. And then we go back to the qualitative again through this protocol to make sure that what the results we have, which are pure technical tests, actually also still follow the needs of the people. I think it's really important is this move between the two, each leading each other each time, rather than going in different that are not necessarily reconcilable.
For example, we know that consumer want high heat stove, but the very high heat does not fit the way it can cook rice. Sometimes it's heat on the bottom of the rice. So the protocol that we want to look at it is the level of heat that is suitable, that could be suitable use of the people. Because if they cook rice, they do 2 things. They would cook to the point that the water evaporated, and then dump the rice into, and that it can be too high because it will burn the bottom. But the second, it could be high because it needs steam. So that we need to look into.
Yeah, I think it's, what we have, the findings and the information we have gathered has sort of contributed to informing the types of technical tests that are done, and also engaging the end users in actually applying it and testing. And that information, as I said, will be fed back to developers. But I don't think also another point, all this information is useful is in terms of outreach and sort of behavior change campaigns and so on. We have a lot of information that would be useful if you don't market and try to sell the stove. And you have a lot of information information on different users and what their needs are and so on. And some information on the pricing, and that's also merging all of this together.
Questions in access to information for the final consumers, define pattern in their consumption, in either gender or different regions, or you're gathering some consumption habits or something. Because I don't know if could be the complex should be a new device design in terms of instructions for the final user, or is the final consumer aware of the information of well best way to use my Cookstove for use? You mentioned health impact, right? So you need older variables, sensible variables on this?
Yeah, I mean, some general messages that come out very clearly, that sort of apply more broadly. But then what we found too is that the way people cook is very different in different locations. So that would have to be taken into account as well. But being said too, you can also have, 10 different stoves. You have to find something that, kind of addresses the main needs.
You mentioned there's some tolerance in terms of, how long it takes to get water boiled. I mean, you through these interviews could get some sense of the tolerance for the products instead of just the, world. And I just think to know where
We have
the preferences are, but today 3 pots, 5 pots, 20 pots, whatever. And an obvious thing, I think, talk to manufacturers also about the preference of consumers. They must know those in the products that are currently being used. They have some, threat in this area. They might lead on what, why people like what they like and why they like other things.
one social science team was trained to get was an opinion about time. People are very good at guessing how long something's been doing something. So, but they have a feeling for what they expect from their stove. So in Jakarta, people expect 1.8 watts per square centimeter. That's into, by math, you can turn that into how long it would take to boil 1.5 liters of water. How long it would take to boil 4.5 liters of water, or 25. So in Sumba, people typically boil 20 liters of water. They want it in 15 to 20 minutes. That's an enormous fire. So it's also big, and if you calculate how much heat's actually getting in per centimeter, it's in the 3.5-4 range, and that's a very valuable piece of information. But we can't trust them to tell us. We have to measure it. So what we do is we wait until they're doing something. This is observing and saying, "What you're doing? Tell me what you're doing." A big fire? Yes, that's a big fire. I mind if I interrupt you for a minute? I just like to put my calibrated pot on there. You put the pot on and just watch the temperature change for about 2 minutes and take it off again. So carry on cooking. In that 2 minutes, we get a hard number that's related to an opinion. And hold the opinion, but we've got the number. Now we have a target, a performance target. And it'd be any stove, any pot, anything at the time, as long as when we do our little tiny experiment for that 2 minutes, we know what we've got in hand. And later when we say, is that low power? Oh, yeah, that's good low power. Is that what it has to turn to? That's okay. Do you mind if I interrupt you for a minute? And then just put it on there. And then with this information from different sources, then we pick up the range of performance and cooking power that we actually have to feed. And of course, the numbers of the pots they come back with, they use pots this big to this small and so on. Then we have a feeling for where do we want to place a product that would have a broad acceptance. Like everybody has a stove about this size, and almost everybody has a much bigger one, but they don't use it very much. But they've all got one. Maybe that target.
Of comments and questions. Rainy Chang from the Global Alliance for Clean Cookstoves and the Director of Standards, Technology, and Fuels activities. I think it's really nice to see you guys present the framework that combines the quantitative and the qualitative and the usability and the performance. And I think it's very aligned with a lot of what other people are doing. I think Yabe comments on that divide between the usability and performance maybe was true 10, 15 years ago, but I think a lot of people are finding different ways to bring those two pieces together, and I think there are a lot of new ideas that you guys have brought forward that a lot of these people came from. On the development of the social protocol, calling it now, what winds up being named eventually, I think there are a lot of resources that we have and a lot of people that we can connect to share ideas on that, so I want to make sure we connect on that. And I also had a question about the analogy of the cars and highway driving, and use highway driving to represent all types of things. So we have the city and highway gas miles. So the question is, where's the line? What's the minimum number of scenarios? Because you could take it to the extreme to have hilly and rainy day and sunny day driving, and a city like Los Angeles and a city like Manhattan. So there's some level of detail, probably too much, and then there's some that's too simplistic. But based on how you guys are combining the technical and the social pieces, like what that no balance is getting information that we need, and it's also with the resources and time that we have.
And if I may I complete your question, just want to add one more, that even when we're talking about sort of highway miles and in driving or city miles, both of those do present highway driving or city driving. So in both of those cases, what you have is a standard you picked, and that standard for all the cars.
In that case, I may want just to in this world, what is being compared right now is not only highway versus city driving, it's tuk-tuk, cars, trucks, bicycles, motorbikes, airplanes, and I don't know what else, and boats. So that is part of the problem. Is you do not have the same standards for boats on lakes than you should have for highway driving. All of those are engines or stoves, and that's one of the messages that we're passing on. It's actually, there's such a variety of things. And if you're talking of heating versus, just basic cooking and things like that, that's why we are moving on. And I'm a little reluctant about this highway versus non-highway, because here we're talking of a very clearly defined engine. And it's a false friend to use that case. Just wanted to.
Yeah, I think that's fair. I wouldn't say that people would want a different metric for each of those different transportation types, but maybe there's like a common set of metrics and some minimum set of burn cycles. But my question is, what is that minimum? What is detail so that we can't manage it, and what's too little detail so it's not providing? How do we define that level or that medium amount?
I appreciate the offer of the resources to check this out. One of the things that the technical people are not comfortable with is to go community with the stove product, and we don't know what they do, and then wait, we're going to find out. No, my stove is good. I've tested that. Yeah, just wait. We're going to find out first what the people do. That insecurity of going to the community and then coming back and saying they don't want your stove because it doesn't do anything they want. My stove is so good. Yeah, right. So it's thing to do in any community or region. We're doing a whole region of Central. The culture is not so diverse that we can't make sensible assessments. It's what we have to hear from the field. We were in Maputo that most people had 5 charcoal stoves in their home. The assumption was from the beginning, 60,000 homes is 60,000 stoves, and 350,000 stoves in those 60,000 homes. So that just wasn't expected. Coming into Java, we find people have very small stoves up to huge stoves, which we titled party stoves, and have 4 to 5 stoves plus their LPG or kerosene stove in every house. Because they do this range of things. And so we sort of say, we need just a lot more information from the field, because I think there's so little that I'm very willing to say, I'm not nothing, let's hear from the field. Let's have some input about, like surveys of what people are actually doing in cooking, because we're too much guessing, I can say. Now we're kind of stuck with, where do you plan to do a project? Good. What they do and how they do it, and with pots and what during the year, or does the meal size change a lot during the year with the season? That sort of thing. Then we'll try to make a stove which can do that. Biomass are quite difficult compared to other stoves.
I do like your question, because that's a question our team debated. Well, because we have social data, we have the collection. Okay, what people usually do, but to classify the 10 cooking cycles, we all down to 2. Because consider, okay, you do 10, how long is a test last? In the lab to test a stove will take a long time. So we have to judgment in terms of not typical. And this may not apply to everywhere in Indonesia. As mentioned, another pilot in Sumba is quite different. The size of pot, the food they're cooking. I think that the overall framework in terms of what are the key metrics we're looking at. The overall efficiency, we all agree that okay, efficiency is important from our side and from user side too. But emission from the development perspective, we care about people emissions, indoor air pollution, so emission over the cycle. I think we need to, in the overall framework, agree on the key metrics and then the local situation, and based to have developed the more step by step in terms of how to measure exactly.
So picking the 2 cycles that we used was to interviewing the social science interviewers and get them the list of a whole bunch of cooking cycles, actual meals that people cooked home after home after home, and pick 2 most extreme examples of power and control. And if the stove could do that range, we knew we were in good territory. So the technical test consisted of only these 2, and they were deliberately picked for the highest average power and longest low power version of actual meals that were popular. And that was how we went with 2.
So a couple of options. You could either say, let's take the bookends to represent the range of the scenarios, or you say, what's the minimum set that is similar to the most cooking practices? Was that you guys went with the bookend approach versus
yes, definitely. Because we went with the middle and what most people did, and the stove couldn't do high and low power, people won't buy it. After they've got it, they can operate it as they wish. So it's not just a test of emissions when they're doing it, it's that can it even do it?
It's easier to find a minimal set then, because if you're trying to represent and be similar to how people are cooking, you probably need 20, 30, 40. But if you want to pick some bookend, it allows you to maybe smaller scale.
However,
be happy with
the
5.
bookends that are representative of actual use. It's not bookends out of nowhere. Those are
bookending the actual
bookends of actual use. That's very important.
Common food.
In this respect. Another thing also, which I think is important, and that I'm hoping will come in the future, is that stove manufacturers will realize that they can focus on specific tasks. What Crispin was saying, water boiling is a specific task. Not everybody has to do a car. Some people want to say, I'm focusing on tuk-tuks, and my efficiency is there. I can pull efficiently from one point to another, and so on. So to keep this interest. So they have stove that will be focused on deep frying or just water boiling, per se, with this light and forget stove. And by not trying to have the average that can do everything, we can become a lot more efficient. Again, in Indonesia, we found that you do have already a lot of specialized stoves. You have cooking stove, you have rice heat stoves that keep heating stoves that just keep the rice hot after it's been cooked. You have a whole range of specific devices that can take part of the cooking and which could be marketed this way specifically.
But if I may, what you're saying sort of brings to the fore one more question, which is doing all of these tests? Are doing these tests because the valuable information that we will feed into the manufacturer, and they're supposed to feed the particular market, whether Ireland or Jakarta. Are these tests because we want there to be a minimum standard that we're trying to make almost global? Are we on, for example, what are the kinds of stores that as the bank group we should not support? And so there is sort of a floor below which we should not. I mean, in other words, what is the objective of these tests?
So you see that mention a little bit in the how this testing fit into the overall clean initiative program. So our objective is to help people to adopt cleaner cooking and link to a more development objectives like in like a health impacts or the poverty reduction, etc. So stove, clean stove, education, first, right? So that's how you define. So you have to have some tests to say, okay, this stove is performance this level versus the baseline is that level. So this is the first step that we are doing, that to say, okay, how to define testing protocol, relevant protocol, and this one is try to capture the local area. Because in the end, we want this, we think cleaner actually will be also adopted by the market, adopted by the users. The hope is to identify the cleaners we want to support. There is incentives associated with this rating. It's star, 1 star, 2 star, 3 stars, to provide this incentive for the private sector to distribute, to market their stores.
Yeah, I mean, I think from the sort of the social side of it, we want a stove that's clean, absolutely. There's no point having a clean stove if no one is using it. So gathering all this information really to get uptake and the sustainable use in the long run, and have more information of what the end users want is important in that regard. And some of that has already been integrated. When we are moving to the next phase with this social protocol guidance, having some of the issues that end users, that's very important to them, easy, fast. So let's test and see if it meets those objectives as well. And if it does, well, the chances are more people will do it. If it doesn't, maybe the developer can do it differently, maybe not. It's really, it's a two-side. Having the right technology, but having something that people can use and want to use.
So may take a slightly contrarian view. Standard, which going back to the analogy of cars, which means every car should be, right? It may have leather seats, it may have to have other things. And make car is miles an hour in terms of 10 miles an efficiency, made for inefficiency. There may be several different things that are characteristics of a widget that you pick up, right? Now, the point that I have to focus us on is, if we just look at what are those characteristics which we absolutely must have. So, for example, we should not have carbon monoxide more than XYZ in a household, because that will, you're basically making the persons in the home sick. So whether that's Indonesia, whether it's Nepal, whether it's India, that of carbon monoxide should not be there. So that's something that we can sort of all come to agreement on, is a universal, right?
The Health Organization has guidelines.
Right. So that's a universal. Now, when we come to different that people are cooking and different things people are doing in their homes, I am wondering a role we have there. So in other words, if I come up with a standard, whether carbon monoxide or particulate matter or whatever, I give it to the private sector, and at the end of the day, these are the standards you have to comply with. Now, obviously, if you are selling in Indonesia, you will be making stoves as if they are selling. If they're selling, the private sector will shut down and elsewhere. So why have to become the guide to private sector exactly how they need to design the stove, whether it be 3 pots, 2 pots? It's just taking a contrarian view and asking that question. I think that's
Can I add a comment on that? My name and I work in India, and we support clean startups, and those include stove manufacturers and they ask a question, want to know the market assessment is the biggest challenge for them. So I see an innate interest in people who take the clean cook stove as a market opportunity for them to totally run business. So I think there is a genuine interest. Questions actually on your program is how the information you gather so far is going back to the companies that are manufacturing the stove. And that's one. And then secondly, you also test gathering information on the cooks having sold to the user, and then how that user experience is also affect their perception of cook stoves. Because, you know, the things that we hear is that you know, a customer is a relatively poor performing stove, and that becomes the idea of a cook stove versus the traditional method of cooking. That venues are working on improved performing stoves with better post-sale services, worried about the bad reputation impacting their business.
So maybe
Okay.
also.
There you go, and then I can add.
Okay. So first, if you look at, there's one slide to show the metrics in terms of, as a program, looking in terms of performance metrics, which is efficiency, CO, PM 2.5, minimum requirement on the safety and the durability. So that is the with the requirement eligibility criteria. First, though, to enter the program, to receive incentive. Receive incentives means, okay, the cash incentive if you sell stoves and additional technical assistance to help you. Because the stove now identified as is good, it's very compared to the base stove. It's clean and more efficient. Just announcement that I think we first batch of testing is finished. So I already identified a few stoves. The final will be announced in early November, and on November 4th, actually will be call for market aggregators, which is okay. Now that the stove is eligible for this list of stoves, you're welcome to sell the stoves, because you have to connect your producers, distributors, etc. each of the set of requirements. And if you're able to demonstrate that the results, we will separate the verification team to monitor the results. And if you meet that result, you get incentive, you cash. So that's on the program side. And there's additional information like controllability, like a certain size, which we ask additional information like guidance, like we found on the market. If very successful, you may want to look into it. It's not a mandatory requirement, because in the end we cannot control actually what the stove, what the type, what the color stove you want to sell. But this is we found that in the area what people like. So basically it's offer. Because we say that the market access, market information is a key barrier for the private sector. It's free, it's low cost to get all this information. And the program want you successful, we offer those information for you. Maybe later on, as a product, we develop protocol, and some companies they can do themselves as a market. So
I think your question is very fair. I think from my perspective, I think the World Bank's perspective, we want to see the end users' well-being improved. This is what we are not setting out to make private sector picture. That's mean. No, I'm not. So if we can make some information available in a systematic and an easy way that the private sectors and others that we work with can grab to easily, then in the end we feel and believe will have an impact on the user and increasing the uptake as a good public good and a role that we are feeling and that we should fulfill because we have increased chances of this initiative being successful. So that's coming back to you. Then in terms of your comment in feedback back to the end users and so on, that is something that we are actually recommending in the outcomes of the study. We haven't gotten that far yet, but yes, something that we used to do, how that would be done and the cost of feasibility, so that needs to be thought further.
Perspective on the issue of, we standardize the performance absolutely, but we to standardizing the usability components because that's a market-based thing and that'll work itself out. So I think, yeah, I talked really well about the from a program and the perspective that I want to lay out from what we're doing from the Alliance is related to data transparency and sharing. And that we want to do is help and manufacturers share information about the performance, about the usability-related features, about the price, about the availability, and that can be taken on so that we're not making judgments on a particular performance level or particular usability criteria, but that information is available for people who need to make that decision, like distributors who are thinking about users, for example.
For me, reason I think lies in the fact that you're going to replicate cooking cycle from two perspectives. One, to facilitate the design of a cooking stove, and this is because you think that the same cooking cycle can be used to determine the performance of a stove and compare. I think it would be better to kind of separate the two and say a whole set of acts are taking place in order to understand the actual cooking process and what the environment is in a particular community, and therefore to inform the design process. And the second, to then break those cooking tasks into size which can then be used to determine the performance of the stove and come to a miles per gallon kind of a measure. And very depending on how you divided up your cooking tasks, how unique they are, and what proportion, what ratios of the cooking tasks are then used for the specific units to get to an aggregate number. I think what Kristen has been talking about. But it is important to not get confused by what they use in order to accept a cook stove, and as to how a cook stove actually performs for a range of given tasks. The two need to be separated. One is for the information to the private sector to facilitate a design. The other is the evaluation, especially for a result-based finance sort of instrument. But you're giving them information to design, and then afterwards, after they design the stove, you compare different stoves that may be there. And the two are different things and have totally different considerations. One related to cultural preferences of the users, cooks, and so on. The other is related to how you standardize or break down the cooking tasks into the activities, use a particular weight factor to determine a single number.
I think that's actually not correct. I think that's actually correct. I think what's being tried. First of all, congratulations! A great presentation and a lot of very good information, and it's really good to see education going on. And too many years we haven't this program. You know, we've had many failures, and the reason has been we haven't really looked at the practices, and you've actually set up some tests to look at some normative practices, and providing them, you have tests that actually, measure things that on a little more complex scale rather than just pure boiling water or simmering water. But I think these tests are really for, stoves have had such a history, are really informing consumers, also providing incentives to manufacturers to produce better stoves.
Yeah, just
So the system which Yay has mentioned, they can use that. Well, do I want more efficiency? Do I want more power? Do I want more? Do I want less CO, in my house? So those, based on those stars, the consumer can make a choice on in terms of what stuff they use. Besides hearing from the neighbors and so forth. Then also, I think one of the things that's been impressive about even this program so far that hasn't even sold a stove yet, that the manufacturers have come up with better rating. And I mean, I've been some of the figures I've seen on the PM emissions have been astounding, and means that the manufacturers have really looked. Now they have a sort of a break against they can perform. Then starting to actually think about, well, okay, how do we develop a stove that actually performs good in this? Now, this is a double-edged sword. Wrong test, we're going to get the wrong stove. So the cultural factor, which you've talked about, is actually very, very important for helping design the protocols for the test. But I think this is a very innovative way. Great job. The team has done a great job, and I think you just underestimate the incentives for both the consumers and the manufacturers in terms of the stove testing. And this things that in the past that we've really been missing. It's a very difficult, an easy thing. This testing of stoves is not an easy thing. There are so many, as you said, that you have to look at. But to a certain extent, I think in this program, because you've done all the the cultural patterns that people are using stoves. Now, what does this mean looking for the future? Well, I'm hopeful that it comes up with a flexible protocol. In other words, you, Crispin, identified like high, medium, low, and then different times that people use high, medium, and low. And then you've already shown that varies by culture. And then can we sort of standard these things and then look at different cultures and different patterns and say, okay, well, this is how they cook here, and they use this high, medium, low, and so forth, and can then adapt the protocols to those areas. It means we won't have a protocol, but it would be important for them to use. At the end here, I do have one question that I want to ask, besides that long statement. How different is your protocol compared to other national protocols? In other words, how different are your test results compared to standard international protocols that are out there?
What is, of course, we light the stove and we run it and measure things. Okay, so to a certain extent, it's very similar. What we measure is slightly different. We choose as the metrics to do the calculations is a little bit different. A lot of people have been reporting the heat transfer efficiency. And my early interest in investigating the stove testing was that the development of stoves which were not foreseen by the early designers of the test and were getting outrageously good performance when clearly they didn't have it. And I started to look into how can that be? Where does it come from? So the calculations which are done and then my careful explanation of the overall thermal efficiency or the system efficiency, which is I think they're being told the efficiency when they're told the heat transfer efficiency. And this is a very big mistake. So if you have a stove that is 53% heat transfer efficiency, but only 19% efficiency in taking out of the forest, that could be a very significant misguide. I left a slide there to show you that with some calculations if you had time to read it. So the way the test is done is pretty much the same. The kind of equipment is about the same. The calculations are simpler, I can say. We only calculate, like Occam said, don't multiply more you have to. If we get away with one or two processes, then we get an answer that's quite precise, and we don't make it more complicated basically you lose information when you do that. So generally speaking, the processing is simpler and the metrics are more straightforward. And when if you ask me how something and I give you an answer, it is the answer you thought you asked. That's quite important. And there's no confusion existing between the manufacturer, the social science team, the implementer, and the tester. We need to be on the same page. So that's it. They're basically the same, but the cycles are definitely different. The cycle we're doing is informed from the community, either a village, a region, it could be a nation, or whatever makes sense. So within China and Indonesia, the variety is so large. There's no way they can have a national test. It just is. You can do it, and it won't help you because the nation doesn't tell you anything. You know more than that.
I think this is similar to a lot of the discussions that we had last week in Guatemala at the ISO standards meeting, where I think there was a lot of the protocol progress is kind of heading to the same place, and that we want some need in some framework, but we need to have flexibility for different stove types, different regions as well, but comparability as well, you alluded to. So I think that's the topics that have come up today, I see as a place marker in the table of contents that's in progress. We still have to work out the details, but there's a lot of agreement on kind of the underlying core of the different components for testing, including the relationship with field testing and with the social science components as well.
And Crispin, how possible or how likely could it be that a stove that tests absolutely superbly under this current series of tests that you've had, local and using the cooking cycles in Indonesia and using in Indonesia, would test terribly in Sudan with a different thing? How
Very likely. I'll give you an example. When you want to design a stove to burn damp fuel, so you're a tropical environment, you do a lot of preheating on the primary air. And you do that to deal with the moisture because you know it's going to be there. And when you know you've got really dry fuel like Senegal, you have to be very careful not to do that. You exclude all preheating on the primary air, and you try and make it highly controlled, and you don't want to have very much of a retort type of feature, or it just produces so much gas you get a big flame and it goes out. So the fuel specificness, there's so many fuels, but at least you can take the general environment is really dry versus really wet. You definitely build the stove differently, and you cope with that really well. And even when you have a low power, to control the stove low power, it would be a different feature from one, say, China, which uses the blowtorch school of cookery. Then you just have to, how much power can I get into that pot in how quick a time from ignition? Why? Because that's what people want. They're going to buy that.
I think the whole issue of data transparency comes in that if you're testing with damp fuel because that's the local condition, then when we talk about the test result, we need to make sure that's clear so that we understand how it can be applied or not applied.
Questions?
Just a question about perception. What do you think are the challenges for manufacturers to build a cookstove that is perceived as just the previous one? I mean, you have a lab to gauge if the current cookstove was worse than the other one. And I don't know, for example, a big fire may be perceived as a good thing, but when you come up and measure it, it is, I don't know, for the way transfer the heat, that will be more efficient, right?
So I'll use it as an example. There's a study that was conducted in South Africa, a very professional one, on asking people what they liked about their stove and what features they wanted. And answers which we got in South Africa were very different from the ones in Lusaka. So when you take all the things that could be, speed ignition is a very common one. How fast does it light? Cooking power, fuel flexibility, pride of ownership, cost, access to the diet, even if the cost was high. Is there a way that I can access the stove as opposed to buy the stove? All things, you list them all, and so on. Then rank them. And so the pride of ownership was third, ahead of fuel efficiency. In lack of pride of ownership wasn't on the scale. Wasn't there. So it's a culturally determined answer, what these questions are. So when a manufacturer wants to make a world stove, he has to have a suite of stoves. It's a fact. You just can't please anyone, because let everyone. So the ranking of these things is very important. I hear from the social science team what people like about their current stove, what they like about their current stove, which would be the things they could have, which of the negatives, which one do they want to get rid of the most? And one for Indonesia is these stick-fed stoves, which is to make sugar, have to be fed every 5 minutes. You have to every 5 minutes, 8 hours a day or 11 hours a day, and they hate it. So a chance for a 10-minute refueling, a huge positive response to that. And 20 minutes was a dream, and they knew exactly what they do. When I asked them, what would you do 20 minutes? I would go there, I would do this, I would do that. They knew just how to manage their time. They hated that 5 minutes more than anything else. They would buy for $50 a stove that they could refuel every 20 minutes. And that did, when we said, how much could you pay for a stove? They said $15. But they could do that. If I had electricity and charge my cell phone and watch my TV, now we're willing to pay. You have the right question.
I understand these sort of more user preferences rather than performance. Preferences change over time. People something different, the sort of baseline can shift, or they can use those things that they didn't like and maybe more. Do you see it changing, or are they probably constant?
It definitely changes as people move to town. And people move to town and they have to do the same things in a smaller space. So it's reported that he's very clear now that in urban areas, people are dividing their kitchen because access to LPG is got to be or something. They are dividing the kitchen into two kitchens, a dirty kitchen and a clean kitchen. They have dirty pots, they have clean pots, dirty tasks and clean tasks, and often the dirty tasks go outside. So that's definitely different from what you see in the rural area, and that is going to be more and more common. The thing they're doing outside is heating water. And if you have a clean water heater, dedicated water heater with a high performance, it moves to the clean part of the kitchen with a fuel such as wood pellets. We can be very, very clean. So that it's definitely evolving.
Chris, one question I wanted to ask on the fuel processing side.
Yes.
I mean, maybe I missed this in the early part of the presentation, but was there also some emphasis on the food processing side in this particular?
We were told that we would have pellets available. That is, the pellet industry was going to make pellets available, and we are testing pellet stoves. Some stoves can burn wood or pellets, and we're testing them both ways as two separate entries. They get two different ratings. And if there is no pellet available, we probably won't support pellet stoves because we can't be sure that there's any for it. And I can't really guarantee it's available until there's that market supply needs to be developed. There are pellets made in Central Java, but they're not available in the city.
That seems to be the way of the future, but it's
coming, yeah, not in the pilot.
It's a difficult market against LPG.
Yeah, we can market.
Okay. But if questions or contact me, stay tuned. We will disseminate what we've been doing.
Thank you. We probably compete against LPG with a known wood pellet of a known size. So let's say 8 millimeters, 8% moisture, packaged with the emissions of LPG in almost all cases. It's very, very clean technology.
In fact, that was where I was trying to go with this, which is that in a certain sense, the operational seems to be LPG.
Yeah.
And so there's obviously a lot of work that's been done over multiple years on the biomass side. But the aspiration always seems to be that, okay, people would like to go there. To a certain extent, if we have solid biomass stoves, we can pretty much mimic it. I think the third person who's telling me this, that we do have solid biomass stoves that use pellets that can pretty much mimic LPG. Maybe that's the area for focus or.
I think it's worth going after, and remember that LPG is a highly processed fuel. Why can't we have just a little bit of processing on biomass? Come on, let's be reasonable.
So, okay, I think how people already left. Sorry, I was having. So I think we have very good discussions. And with that, thank you very much, Crispin. So, finish this. Okay, please.